Welcome to Module 4, Lesson 2, Constant Rates of Change. So today we're going to talk about proportions and how we can find the constant of proportionality, which is also known as the unit rate. And we're going to find those in tables and we're going to put them into equations. We're also going to find them in diagrams, verbal descriptions, and we are going to decide if two quantities are in a proportional relationship through equivalent ratios. Right? And then we're going to use that constant of proportionality to write equations. All right, so first we have a problem here where we have a giant tortoise who moves at a slow but steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches, right? So if we take our bar diagram here and we go ahead and draw our 10.5 inches. So you notice here we have our box that shows our 10.5 inches. And I'm going to go ahead and get my magic eraser here. And when he goes 10.5 inches, it takes him 3 seconds. So we section that box off into 3 seconds each. All right, so then I'm going to look at this and I'm going to see what operation did I use to find the answer of how long it takes or how far he goes in 1 second. Well, I know that I'm going to divide by 3 to find that answer. So then I can take that and I can put those answers into my table. So when I do that, when I divide that by 3, I get that in 1 second, he goes 3.5 inches. So then in 2 seconds, he will go 7. And then in 4 seconds, he will go 14 inches. And then in 5 seconds, he will go 17.5 inches. Right, so now if I take each of these ratios or rates and put them into, or each of these columns and put them into a rate, I can take a look at what I get for my rate of speed. So here I have my first rate, which is 3.5 inches in 1 second. And if I reduce that, or if I divide it, I get 3.5 seconds, or 3.5 inches per second. Here I have 7 inches in 2 seconds, and if I reduce that, I get 3.5 inches per second again. And then here, again, 10.5 over 3 seconds. And if I reduce it, I get 3.5 inches per second. 14 inches in 4 seconds, which reduced gives me 3.5 inches per second. And then if I do 17.5 inches in 5 seconds, that reduces once again to 3.5 inches per second. So each of my columns, when I put it into a rate, when I reduced it, I found that the unit rate for all of them was the same. So what I call this is a constant of proportionality. Constant of proportionality and unit rate can be used synonymously if the unit rate is the same for the entire table. Then it is a constant of proportionality. Notice the word constant. That means that it has to be the same the whole time. All right? It cannot be a constant of proportionality if it is not, in fact, constant. All right, so what do I notice about the decimal forms of the fraction? They are all the same. Okay, so how do you think the distance a tortoise travels is related to the time? Well, what you'll notice is it's constant. It never changes. All right, so as we said before, it's slow, but it is a steady pace. Steady in this case meaning it is constant or never changing. All right, so suppose the tortoise travels for 12 seconds, which was not on our chart. Explain how you could find the distance the tortoise travels. So what do you think that we could do? How could we find the distance that the tortoise travels? I want you to take a second and think about it, and so then write it down and see if you're correct. If you said that we could take the distance that he traveled and multiply it by 3.5, his rate of speed, or the time that he traveled and multiply it by 3.5, you would be correct. So if we take the distance the time he traveled, which was 12, oh goodness, that is a touchy board today. So 12 and multiply it, try this again here, and multiply it by 3.5. 12 times 3.5. 2 times 5 is 10. Carry the 1. That's 6. 2 times 3 is 6. 1 times 3 is 3. 0. 12. Carry the 1 is 4. I get to move the decimal over once. Okay, so that would be 42. So I know that he would have traveled 42 inches. Right. So how would you describe the rate of speed at which a tortoise travels? Again, we could describe that rate that he travels as constant, okay, because it's never changing. All right, so here we have Callie who earns money by dog sitting. Based on the table, we want to find out if the relationship between the amount she earns and the number of days is proportional or not. So first what we're going to do is we're going to write down each of the rates. Now to write down each of the rates, we have to take the columns. So I have to take the columns and write them together. Now we have to, again, think logically. Do we do money over time or do we do time over money? So is it days per money or is it money per day? We'll usually get money per day when you are earning your wages. All right, so again, let me get my magic eraser out here. So first, my first rate would be 16 over 1, so 16 for 1 day. And my next rate would be $13 for 2 days, $48 for 3 days, $64 for 4 days, and $80 for 5 days. And again, I would need my labels. And then now we are going to compare these rates. So just as we did before, we're going to take a look at those rates and we're going to reduce them. We're going to take a look at their unit rates. So here, if I take 16 over 1 and I reduce it, I find that it has a unit rate of $16 per day. Here, if I take the unit rate of 32 over 2 days, so I divide it by 2, I get $16 per day. Here, if I take $48 per 3 days, I find that I get $16 per day. Again, if I do $64 per 4 days and divide it by 4, I see that I get $16 per day. And here, if I do $80 per 5 days and divide, I find that I get a unit rate of $16 per day. So I found that in this case, yes, I did get a constant of proportionality of 16. Typically, our constant of proportionality is represented by a K, and it should be lowercase, and I have a hard time writing lowercase k's, so you'll see I make a loopy K. So my constant of proportionality in this case is 16. Okay, and my constant of proportionality is $16 per day. So yes, the rates are proportional because they all have the same constant of proportionality, which is $16 per, and that should say day, not per hour. So per day. All right, so now you have your time now where you're going to take your opportunity to look at the table and see if the table represents a proportional relationship. And then when you come back, we'll take an opportunity to check your answer. All right, so you should have found that no, she did not drive at a constant speed. The rate of speed changed right away from 65 miles an hour to 60 miles an hour. So you'll see your first rate was 65 miles per 1 hour, but then your next rate was 120 per 2 hours, and when you reduce that, you got a unit rate of 60 miles per 1 hour. So right off the bat, you found that your unit rates were not equivalent. Therefore, there's no constant of proportionality, and your rates are not proportional. All right, so now we're going to take a look at 2 pounds of cashews that are shown here. They cost $19 for the 2 pounds. So $19 for 2 pounds. And 8 pounds cost $76. And we want to show that the relationship between the number of pounds of cashews and the cost is a proportional relationship. And then we want to write an equation for the relationship. We also need to note that 3 pounds is $2.85. Okay, so first we're going to make a table. We don't always have to make a table, but we're going to make a table so that we can get used to using tables to help us write our equations and form proportions. Okay, so writing our table, I have the 2 pounds that cost $19, the 3 pounds that I see from my picture over here that cost $28.50, and 8 pounds that cost $76. Okay, I'm now going to write my rates. Okay, so I have my rates, which I have the 19 pounds that cost, the $19 for 2 pounds, which costs $9.50 per pound. I then have the $76 for 8 pounds, which when I divide for the cost per pound, I found was $9.50 per pound. Then I could also double check, and I could check and see, well, $28.50 for 3 pounds. I could divide both of those by 3, and I could get my trusty calculator out here. And do my $28.50 divided by 3, and I get $9.50. Now, just because my calculator didn't show that 0 doesn't mean that it's not there. We have to remember it is there because it's money. Okay, and I got $9.50 for 1 pound. But now we have to write an equation. And to write this equation, I have to think of what the variables represent. So my first variable that I'm going to think about is x. Okay, x is the independent variable. And the independent variable means it doesn't depend on anything else. So the number of pounds doesn't depend on anything. All right? So the number of pounds of cashews being purchased is the x. The dependent variable, though, is the cost. That's our y. The cost depends on how much we buy. Okay, and then our equation is going to be the cost is going to be set equal to our amount of pounds multiplied by our cost per pound. Okay. And this got a little bit redundant here, so let's try to fix this a little bit. So the cost will equal the total pounds multiplied by the cost per pound. So the total pounds multiplied by the cost per pound. There we go. The total pounds purchased. There we go. That makes a little more sense. So then now our equation would be y equals $9.50, so $9.50 times x. So if you think about it, $9.50 times the pounds of cashews will equal the cost of our cashews. All right, now it's your turn to give it a shot. As always, when you come back, we'll check your answers. All right, so here you should have found that your table would have been 12 students to 1 adult, 36 students to 3 adults, and 60 students to 5 adults. And you should have found that y would represent your number of students and x would represent the number of adults. And that if you took 12 times the number of adults, it should give you your number of students. All right, and last but not least, we have your guided practice. And as always, so make sure you fill this out. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.